Hey guys, this is the first video for Target 1B. That mastery learning objective is being able to rewrite expressions involving radical and rational exponents using properties of exponents. So this video covers 1B.1 mastery learning objective. So we should be able to convert an expression in radical form to rational exponent form by writing the roots as denominators and exponents as numerators. So remember too, kind of a side note, that the word denominator means the bottom of the fraction, right? And then numerator is the top number in a fraction. So the first two vocab words that we got to discuss is, the first one we have is radical. And a radical is an expression that has a square, doesn't also have to be a square root. You can also see a cube, right? A cubed root, etc. Right? That can go on and on and on. And the symbol that you use to write a radical, so the symbol is a radical symbol. So it kind of looks like that in the house. And what we'll kind of see later is that you're going to have a little index number in here. If there's ever a number inside here, that's called the index, or it's also called the root. So that's kind of the number in that little spot there is how it gets the name of whatever root it is, right? Square root, there will be a little 2 in that little box. Or a cube root, there's going to be a little 3 in the box. Fourth root, so on and so forth. But we'll kind of get to that a little bit later when we start converting. Alright, the next vocab word is square root. So this is kind of the most common radical with a root of 2. And since it is the most common, you never really see that 2 in that little index box that I was writing up above. So the 2 is not written. Think back to the previous videos when we were working with coefficients. You know, sometimes if the coefficient was a 1 in front of our variable, you never really seen it being written. Same thing with our square root. Since that 2 in our index spot is the most common, you never really see it. Alright, looking at the next part of our notes here, there is a kind of investigation for you guys to be able to see some comparisons between expressions that have radical symbols and also expressions that have our exponent as a fraction. So we're going to evaluate some of these. So the first one I'm looking at right here is going to be the square root of 25. And so this is the problem I'm going to look at. This is what I'm going to do first. And I'm going to go ahead and get my calculator up and going. And hopefully I can have this working side by side nicely. Feel free to grab your calculator and follow along with me. But for some reason, my calculator is being hidden. Alright, so in order to get that little square root symbol, what you're going to do here is you're going to kind of use these little buttons over here. In order to get the square root sign, you have to press this blue control button first, and then the x squared button. So that x squared button is located one button left to the 4. And you'll notice that on your screen comes up our little radical symbol. So all you have to do in there is go ahead and type 25. Click enter, and what you notice is our answer is a 5. So I'm going to go ahead and just write that in here. We know that our answer, oh, I lost my pen, bear with me, is a 5. Alright, now looking over to our question over here of 25 raised to the 1/2, in order to write that in our calculator, what we have to do is write our base first. So remember, the base is the number at the bottom, right? 25 is our base number, and we have to go ahead and raise that to the 1/2 power. So in order to get that exponent button, hopefully we know this by now, you're going to click that little up caret, and then you're going to go ahead and type in our fraction. So you're going to type in 1 divided by 2. Click enter, and you're also going to see that answer is also 5. Alright, kind of keep repeating this, and then we're going to look at this next example that says the 5th root of 243. Now that one's a little bit different because this one has an actual root number written. It's not the square root. So in order to get the 5th root of something, you still have to push that blue control button, but you're going to select now the up caret that has this little like M and then the square root of an X. That means that you get to actually substitute what that root or index number is going to be. So in our case, it was a 5. And then what we have inside of our radical is going to be 243. And then we're going to go ahead and click enter. And what we notice here is that we have 3 as an answer. So I'm going to go ahead and write that in. Likewise, I'm going to go ahead and do this example on the right side that says 243 raised to the 1/5. And again, you might start beginning to see a pattern here. Again, I'm going to write my base 243. I'm going to raise that to the 1/5 power. And that is 3. Keep in mind that I'm not multiplying 243 times 1/5. I have to raise it, right? It's an exponent. It's not multiplication. Alright, looking at this next example here, I have the square root of 4 raised to the 5th power. So I'm going to go ahead and type in the control x squared to get my square root, and I have to type in 4 raised to the 5th power. And that's going to give me an answer of 32. So I'm going to type that in, 32. Over here in this next example, I'm going to take 4 and I'm going to raise that to the 5 halves. 4 raised to 5 halves, which is also 32. Right, so you're kind of seeing the pattern here. Right, next one, we have the cube root of 8 raised to the 5th power. So I'm going to have to press control and that up root arrow. Have to make sure I add in my root number of a 3, add in my 8 as my base, and then I have to raise that to the 5th power, which is 32. And last but not least, 8 raised to the 5/3 power. So 8 raised to the 5/3 power is also 32. So hopefully you kind of start seeing a pattern of what we had as a radical and what we have as a rational exponent. Remember that rational is just a base that has some type of fraction as an exponent, right? Scrolling on up so we can kind of apply what we just seen is how we can convert things that are in radical form. So this is in radical form, right? And I want to get my radical form into something that is in rational. So remember that rational form is going to have a fraction exponent. Right? Fraction exponent. So let's look at this here. If I have a root number, right? This is my root number. I also use the word index up above. You see that that root number, when rewriting our bases, kind of stays there until we actually rewrite our base completely. Our base never changes unless we kind of can simplify, like on the right side of the table above, we were simplifying. So when we have our base, we're going to take that base and we're going to keep the same exponent, and that's going to be at the top of our fraction. So this is going to be my exponent. My denominator of the exponent is going to be my root number. I have highlighted in yellow. Okay, so kind of looking at that, you can go back and forth. Our exponent never changes, right? That's going to get kind of brought out of our parentheses, out of our radical symbol, and that becomes the numerator of our exponent. And then the root or index number, what's highlighted in yellow, becomes the denominator of the exponent. And you should be able to go back and forth between these. Same thing when you have something that is already in rational form, and you want to go back to radical. That exponent is what remains as the exponent all the way as you're converting. And the denominator of your exponent is what is your root or index number. And notice the base stays the same, right? We have that A in all of that example towards the bottom. Now let's kind of look at some of these examples together. I see our first example. We have the square root of 10 raised to that third power. So remember, all common square roots, this index number right here is a 2. We never see it, but it is written there. So please don't forget that. Write it in so you can see it. And then also remember that when we are writing these, we keep our base the same. Our exponent stays at the top. And our root number is at the denominator of our new exponent. So looking at this here, I know my base is 10. So I'm going to bring down my 10. And my exponent here is the exponent that the 10 had already. So looking at that exponent, that's going to be 3. So that's the number I'm going to write at the top of my denominator. As a numerator, I apologize. My denominator is going to be my root number, which was the number that you see over here as the index. Alright? That's all you have to do. You just got to rewrite back and forth. Looking at example 2, we still have a radical here. My base is 2. Right, so I'm going to keep that base the same. Now, I have to be careful here because this root number is a 6. That root number does go down here, and it kind of brings me to, well, what goes in my numerator? Because I don't have a little exponent here. But just like in the previous videos, every base has that invisible exponent, whether we see it or not. And that's going to be a power of 1. So this is going to be 2 raised to the 1/6 power. And we can scroll down now to example number 3. There's example number 3. Here's example number 3. So looking at this example, I have the 4th root of 2 raised to the 5th power. So again, base stays the same. My exponent is going to be up here, which is 5. That is the numerator. And my denominator comes from that root or that index number, which is 4. I'm good to go. That's my answer. Looking at example number 4. Now, we have to be pretty careful here because if we look at our base, you have to think of everything that is underneath that radical symbol. So if there's no parentheses there, it's always safe to kind of give yourself parentheses, only because I need the exponent to everything. I need that exponent to the whole base. And since my 4 has a little invisible power of 1, right? This 4 has a little power of 1, and my letter D has an exponent of a 5. The overall exponent to the whole base is going to be a 1. So anytime your base doesn't have parentheses, go ahead and put it in parentheses and give it a power of 1. Only because when we rewrite that, I need to keep my base all together, right? 4D to the 5th was the whole base. Now I go ahead and rewrite my new exponent as a fraction. My numerator comes from that exponent that we have out there, which is a 1. And then my root or index number becomes the denominator. So that's one of the trickiest things, is that anytime, like I said, that base doesn't have parentheses, go ahead and put in parentheses and give it a power of 1. Only because that, since my exponent right here on D is a 5, you don't want to accidentally put that as the numerator of the exponent. So just be careful. Alright, and then my last question, I have number 5 and number 6. Kind of reiterating the fact that, my base already had its parentheses, so you see how this one already has parentheses. That's how I know that this 3 is the exponent to the whole base. Okay, so I'm going to keep my base together, right? 7x is going to be in parentheses still together. And I'm going to go ahead and take that exponent, make that my numerator. And then take that root number and make that denominator. Also be careful that you actually make your exponents look like exponents. We don't want to see that 7x and then the 3/4 right next to it. You want to make sure that it's an exponent that is up in the air. Just so that I don't think you're trying to multiply those. Alright, and our last question here for this video is, we have 5 times the square root of 2a cubed. So remember what I said about giving yourself that parentheses and a power of 1, just so I don't confuse that cube power on that a. It does not correspond to the 2, right? 2 has its own exponent of a 1, so please be careful. The other thing is, notice that this 5 is not inside of the square root sign. So that 5 needs to stay out in front, right? I don't do anything with that. To rewrite the square root of 2a cubed, I'm going to go ahead and keep my 2a cubed in parentheses. My exponent is that 1 over here. I'm going to bring that over to my numerator. And remember, too, that anytime you have the square root with no index number, that is an invisible 2, right? You even say square root, meaning 2. And that's our final answer, right? 5 times 2a cubed raised to the 1/2 power. Alright, that's the end of this video. You can go ahead and find activity 1B.1 in your activity packet and get started.